Dad, I'm looking forward to the zoo. Oh, I wonder what kind of animal they are. Zebra have beautiful patterns. I wonder if different zebras have different types of patterns. It's a leopard. I like leopard. Giraffe. It's a mesh and it is very big. Oh, what's that? This is urgent news. On July 31, 2023, a giraffe without a pattern was born at the Bright Zoo in Limestone, Tennessee. It is possible that it is currently the only one in the world with a single color. The last documented giraffe without a pattern was Ryoko, born at Ueno Zoo in Tokyo in 1972. According to Tony Bright, the founder and director of Bright Zoo. Hey Dad, how can they make a pattern? Why doesn't that giraffe have a pattern? Hello, it's time to study about animal patterns. Dr. INDE will tell you. Until now, it was thought that animal patterns were inherited from their patterns. However, it turned out that animal patterns were formed according to a certain mathematical formula. This formula is these two formulas. It will look very difficult. It was the genius scientist Alan Turing who found this equation. Alan Matheson Turing is a mathematician, cryptanalyst, computer scientist, and philosopher from London, England. He lived from 1922 to 1954. He excelled in mathematics from an early age, solving difficult elementary calculus problems not taught in school. His formative years were not evaluated before his death. More than 10 years after his death, ACM, an International Society of Computer Scientists, established the Turing Prize, the Nobel Prize for Computational Science. I see. It turned out that Turing is a very smart and gifted scientist, but this formula is too hard. No problem. Dr. INDE will tell you. You can create various patterns by changing the value of the previous expression. If it is 0.25, it looks like the pattern on the front. I think 0.18 is a zebra or a fish. 0.15 looks like a giraffe. As you can see, we can think of the process by which an animal's pattern is made as an expression. The Turing pattern is a mathematical model of how the concentration of two or more substances distributed in space change due to the effect of two reactions. A local chemical reaction in which the concentration of two or more substances change each other, and diffusion in which the substance spreads throughout the space. Simply put, the reaction proceeds according to two assumptions. The first assumption is that substance U promotes its own synthesis. It also promotes the synthesis of substance V. V suppresses the synthesis of U. This assumption also makes a difference in the concentrations of the two substances. The second assumption regulates the diffusion rates of U and V such that synthesis of U is stimulated in some areas while inhibition of U synthesis by V is effective in the surrounding areas. In other words, it changes the rate at which U and V spread. I see. I figured out how to make pattern. Next, let's actually use a program to see the Turing pattern. This program can represent various biological patterns by changing parameters. First, let's generate a giraffe pattern. This variable is assigned to this expression. Let's compile it. It's a little long, so I'll double the speed. Okay, I got the result. Then I click the individual play button. Here, a beautiful pattern was generated. Actually, people have patterns. There is research into human patterns. In 1901, German dermatologist Alfred Blaschko noticed a strange trend in examining more than 115 skin patterns. Skin syntheses such as mole, bruise, and eczema appeared as if tracking invisible lines. This is called the Blaschko line, and although it can only be seen in skin disease, it emerged as a human pattern. Turing patterns are used not only for patterns but also for various life phenomena. Turing patterns are roughly called waves. In December 2012, experiments showed that Turing mechanism was responsible for wing growth, lung branching patterns, and the symmetry of moving the heart to the left of the chest. This theory is supported by many developmental biologists and Shigeru Kondo, who has identified Japanese leading Turing pattern. Shigeru Kondo states, "Perhaps we can predict that genes play a role in determining the general shape of the body structure. In the lung, the branching of the early bronch is probably a genetic blueprint." I would like to contribute to the development of humanity by applying the Turing pattern to regenerative medicine. Patterns of waves and animals, waves and people, and other unexpected things are related and can be applied. I think it is important to study with a big perspective.